Alright, for this video, we're just going to take a look at negative exponents. So far, we've only been dealing with positive exponents, and I believe the last video we introduced 0 as an exponent. Now, let's look at this example. We've already done problems like this, and how I told you how to do these problems is when you divide, you want to subtract the exponents, but you want to keep the exponent where it's bigger. It's bigger in the bottom, so x is going to stay in the bottom. I put x there, and then I subtract. 5 minus 2 gives me 3. So it stays in the bottom there. Now the top just becomes 1. Okay, so that's 1 over x cubed. Now the definition of a negative exponent is if you have something in the bottom, meaning the denominator, this x to the third, if you actually move this to the top, it actually becomes a negative. It's the same thing as saying x to the negative 3. So what you're really doing is you're taking the reciprocal. Now, we don't want to deal with negative exponents. We want to make them positive. So if I actually look at the reverse, if I look at this right here, if I have x to the negative m, and m is going to represent a number, then to make that positive m, I just flip it. I take the reciprocal, so it's 1 over x to the positive m. You know, if I were just to give you a couple examples, if I had x to the negative 4, well, that equals 1 over x to the 4th. I never ever want to be left with a negative exponent. So if you have a negative exponent, flip it. Now, it also comes into consideration if I have a negative exponent in the bottom. If I had, let's say I had 1 over x to the negative 4th. I want to make that positive 4th, so I flip it. I move this to the top, and it becomes x to the 4th over 1. All right? So biggest thing, if you ever start with a problem that has negative exponents, flip them. Okay? If it's in the bottom, move it to the top. If it's in the top, move it to the bottom. Then it makes the exponent positive. All right, let's look at number 1. Very first thing we're going to do, we're going to do 1, 2, and 3. Very first thing I want you to do is to circle all the powers where the exponent's a negative. So for number 1, I have x to the negative 5. I'm going to circle that. And I have z to the negative 2. I'm going to circle that. Now, the ones that aren't circled, this y to the 4th is not circled. I do not move that. I do not touch that at all. I keep it where it is. So y to the 4th, that stays up top. Okay, I put a line through it because I keep that up top. Then I swap these. So that x to the negative 5th, when I move this, I'm going to move this to the bottom. And that x to the negative 5th becomes x to the positive 5th down low. This z to the negative 2, I move this to the top and becomes z raised to the positive 2. So just when you swap it and you change, it makes the exponents positive. And then I can't subtract these exponents because I have a different base, y and x. Same thing with this. I can't subtract 5 and 2 because different bases of x and z. So that's it. You're done number 1. That was just a matter of reorganizing. So negative exponents, that's just a matter of reorganizing them and making them positive. Okay, so if I do number 2, again, what should always stand out, circle the negative exponents. Here, it's just 0 to the negative, or z to the negative 3. The bottom, it's x to the negative 2. So everything that's not circled, which in this case is x cubed, y to the 4th, and yz in the bottom, I leave those where they are. So I leave x cubed and y to the 4th up top. So I'm done with these. I'm going to cross them out. Y to the z, I leave them in the bottom. So I'm done with those. I'll cross those out. Now, the circled ones, I swap these. And when I swap them, then I make their exponents positive. So the z to the negative 3rd, I move that to the bottom. It becomes z to the positive 3. So I'm done with this. That x to the negative 2, I move up here, and it becomes x to the positive 2. Now I can use a couple properties right here. What stands out, I have x cubed times x squared in the top. So this is where I can add 3 and this 2. It gives me 5. So that's x to the 5th. And I still have y to the 4th. And then in the bottom, I have z times z cubed. Z is the same as saying z to the 1st. So 1 plus this 3 gives me 4. So in the bottom, I have 1 z to the 4th. And then I'm not done yet. This is why you can see how these problems get harder and harder. Now I can use the division properties. Here I have y to the 4th over y. Well, y is just like saying y to the 1st. So if I subtract 4 and 1, I get 3 The y's stay up top, so I'm still going to have x to the fifth, but then it becomes y cubed, and then I just have this goes away, and I just have z to the fourth. All right, so we'll actually stop there. Number 3 takes a little bit longer there, but the main thing is pick out the negative exponents. So if you were looking at number 3, I would circle a to the negative 8, c to the negative fifth, and c to the negative 2. Those are the ones that you move, you take the reciprocal of.